IntrinsicNeRF, learning intrinsic neural radiance fields for editable novel view synthesis. Given a set of multi-view images with camera pose, IntrinsicNeRF can factorize the scene into the temporally consistent components, reflectance, shading, and residual layers. The decomposition can support real-time augmented video applications such as recoloring, illumination variance, and editable novel view synthesis. Neural rendering methods with inverse rendering can model the geometry, albedo, and illumination of some objects, but they rely on accurate surface modeling. It may fail with bad geometry. The goal of IntrinsicNeRF is to empower the scene-level neural rendering while maintaining such editable capabilities. IntrinsicNeRF takes the 3D point and direction as input, and outputs reflectance, shading, and the view-dependent residual term. The product of reflectance and shading, plus the residual term, gets the RGB output. When the input is room-level data, IntrinsicNeRF enables the semantic branch to improve the intrinsic decomposition quality. Unsupervised priors and reflectance clustering are exploited to train the IntrinsicNeRF in an unsupervised manner. We show the albedo results of IntrinsicNeRF with intrinsic decomposition methods and neural rendering methods with inverse rendering. Our work combines the advantages of intrinsic image decomposition and NeRF, which can maintain consistent albedo estimation in scene-level scenes. We got the best result on the chair dataset, while IntrinsicNeRF failed because it requires an accurate surface. Similarly, we got the best result on the ficus dataset, while IntrinsicNeRF failed again. Our IntrinsicNeRF can perform room-scale consistent intrinsic decomposition, compared with existing methods. Here, we show more results of IntrinsicNeRF on the replica dataset. Here, we show some applications of IntrinsicNeRF. Based on the intrinsic decomposition in IntrinsicNeRF and our hierarchical clustering representation, we can easily modify the object's color in real time while preserving the original shading effect on the object's surface. Similarly, we can modify the object's color in the room. We can scale up or down the residual term to adjust the room illumination. Here, we show more application results of IntrinsicNeRF. Real-time recoloring on Blender object dataset. Real-time recoloring on replica dataset. Real-time scene recoloring on real-world data. Real-time illumination variation on Blender object dataset. Real-time illumination variation on replica dataset. Real-time illumination variation on real-world data. Editable novel view synthesis on Blender object dataset. Editable novel view synthesis on replica dataset. We have also developed a convenient video augmented editing software to facilitate the user to perform object or scene editing. Overall, we introduce intrinsic decomposition into neural rendering and propose an intrinsic neural radiance fields representation, i.e., IntrinsicNeRF, that can decompose the scene into reflectance, shading and residual layers. We propose a novel point sampling method that allows IntrinsicNeRF with traditional intrinsic decomposition constraints to be trained in an unsupervised manner. To further learn IntrinsicNeRF better, we propose a hierarchical iterative reflectance clustering method with mean shift, which could optimize the network from coarse to fine. Our intrinsic neural radiance fields together with hierarchical clustering and indexing representation can support real-time video augmented applications such as scene recoloring, illumination variation, and editable novel view synthesis. Thank you.